All right, folks, and welcome to another amazing webinar where we're going into round two of our enterprise Wi-Fi Q&A. Ask the experts, because if one wasn't good enough, two's better, right? Because we last time, if you joined us on our first session, we had so much feedback and Q&A that we just had to do another one, right, Tawny? Because
we did.
We got so much content to cover. But what's really cool today is that we've got some amazing guests. These are no strangers to our show, Tawny. They're super friends of ours as well. And you know what? And it's and during this time, it's like, you know what? It's almost like we're all together in the same room, right? But we want to be in there. But hopefully, we'll all be there soon.
Yes.
Now,
as events come back online, yes, one day.
Right? Yes.
One day.
So for all those that are out there, if you have a Q&A question, please use the Q&A panel, and we will actually get those answered, and we'll try to read them out throughout the show today. If you want to chat amongst yourselves, and you can definitely use the chat window there, but throw the Q&As over to the Q&A window if you don't mind. Yes, the session is recorded, but we want to make sure we have as much interaction with you as possible. So with that, I am your sidekick, Stu, and I'm going to hand it off over to my host, the lovely host, Tawny.
Well, I get the easy part. I'm just going to have these guys introduce themselves. I think they're, as you said, Stu, they are no stranger to Ekahau. We are so excited to have them on. Thank you guys for taking the time out of your day. We'll start with Sam. Why don't you introduce yourself?
Hi, everybody. My name is Sam Clements. I work for a large VAR here in the States, and I look after the mobility practice there. I'm a CWNE, CCI wireless, and Ekahau instructor, and all sorts of fun stuff. So in short, I'm passionate about all things Wi-Fi.
Thanks, Sam. Jake.
I'm Jake Snyder. I am a corporate SE at Juniper, supporting the MIST portfolio. And I've been doing that for just a little over a year now.
Very cool. Very cool. And last but not least, the lovely Miss Jen.
Hi, I'm Jennifer Huber. I'm a mobility solutions architect on the global engineering team for a large value-added reseller. I am also a yoga teacher and puppet maker and all kinds of things like that. I have a wide variety of things that I'm capable of doing. But I'm also CWNE and a wireless engineer.
Jen is one of the most creative people, like makes some of the coolest stuff. So with that being said, before we jump right into our questions today, we are actually going to launch a poll and ask a question in true Ekahau fashion. After you have gathered your requirements, what is your first consideration when designing a network? And panelists, I'm sorry, you guys can't answer the question. So Stu, cue my Jeopardy music. I'm putting you on the spot again.
Oh, I was ready.
All right, so let's see as we get these answers rolling in. It's kind of interesting what folks say. So let's actually take a look at that. Pre-site survey. So I'm curious, panelists, what would you have said? Jen, how would you have answered that question? Or how would Mr. Puppet have answered that question?
Definitely a pre-site survey. When at all possible, get to the site and see it with your own eyeballs.
Mm-hmm. Jake, what about you?
Yeah, I'm in the same boat. Pre-site survey.
Yeah. And Sam?
Yeah, I mean, I would have to say, as Jen said, if there's no substitute for laying your eyes on the facility. If I had a nickel for every time I showed up somewhere and saw something that didn't impact my design or something that impacted my design, I'd have a whole ton of nickels. Yeah, super important to lay your eyes on the physical facility.
Well, let's talk about design and why that's important. So why is a good design important?
Well, because garbage in, garbage out, first of all. Garbage in, garbage out. And you can only tell so much from floor plan drawings, because there's always going to be something that you're going to discover in person that maybe was inferred or could be inferred, or maybe is not even present on the floor plan, like big atriums or like hard ceilings or places where there is no space above the ceiling, that kind of stuff. You can't always tell that.
Or windows on the walls, or
yes.
Chicken wire in the windows, or yes. Lead in the walls, or any number of things, or big pipes in the wall. I mean, there's just a million and one things that the floor plans, remember, are a starting point for building a building. They're not a finish point for what that building's going to look like at every point in time throughout that building's existence. And there's, yeah, agreed.
So some folks are already starting to ask a lot of questions. So we'll get to some of them are Ekahau related, and if we get a chance, we'll get to all of those. But Sam, someone was specifically asking, is disabling lower data rates a proper way to control cell size and client connectivity?
Ooh, yes and no.
Yeah.
Can I say that instead of it depends?
Yes.
I think that's a great I think it's a great example of there's a lot of different ways to induce client behavior. I think that by and large, the way we usually shape cell sizes is by dealing with antennas first, then transmit power second, and you intend to have a particular coverage area of your AP, whether that's large or small, and that's of course part of your design, right? The proper placement of the AP, the proper antenna, the proper transmit power, is all those things get fed in first. But then you of course have persnickety clients, and those clients are varied. And so if you get that one client that doesn't really roam well because it sees it has 1 megabit per second data rate supported all the way out till infinity, then yes, in those instances you may have guidance from your client device manufacturer that says, in order to create a harder boundary, disable, and in order to induce roaming earlier, make sure you trim up data rates so that X, Y, and Z client has that expectation as they're moving away. And every client is different. I think that most modern clients, probably that's not incredibly necessary. I would start with AP placement, location, antenna, transmit power first, and then if necessary, go off and start monkeying with data rates in order to get your client behavior to work the way it should. So
speaking of roaming, what recommendations can you make for folks that are having issues with roaming, the clients roaming on the network? Jake, you want to take that one?
Turn the power down. No,
okay, so that brings up another philosophical question.
So yeah, I mean, it always depends, but typically when I see clients that hang on, some clients are just sticky, but the other thing is that a client is going to roam when the AP it's connected to no longer makes it happy. And because everyone has things that make them happy, some of them are high data rates, some of them are high signal strength. Some of it is I don't want to impact my application because I'm moving voice packets. It changes how they want to, what's going to make them happy at any given point in time. The better you can understand that, the better you can plan for it. But I would say in general, when I see folks, turn it up to 11 in terms of cranking up their transmit power, clients are going to see more signal in more places, and therefore, if they are signal based, from in that decision process, they're going to say, well, it's okay. I'm above neg 67. It doesn't matter that their upstream data rates are extremely poor if that's not how they make that decision. So I would say, I think most of the time, too much transmit power is going to lead to stickier and stickier clients.
So you're talking about cranking the power down. What is the threshold between adding another AP and transmit power? What is a good rule of thumb for folks to hard and fast rule? Jen, you want to?
That's a tricky question. Because, you add too many APs, you raise the noise floor, and you're basically shooting your own self in the foot, trying to do something that seems like a good idea at the time. I don't know. There's a fine line between enough APs and low power output. I was going to tack on to the 1 and 2 meg data rate, saying that bit me when I had active RFID tags that required those data rates to be enabled. So I kind of found myself in a situation where I had to support all the things, even though I didn't want to. And clients are going to roam, and clients going to roam. It's tough. It's tough.
It is, and I think that's. Oh, sorry. Go ahead.
I was going to say, I don't know that there are hard and fast rules on when to add an AP or not. It's a balancing act. You're going to trade one thing for another, and I think the key is understanding what you're trading and what you're getting, and that's not even all that straightforward.
Mm-hmm.
Well, and I think you hit the nail square on the head, which is this concept of designing for the least capable, most important device. And capabilities in this instance, capabilities can be a laundry list of things, not just receive sensitivity or transmit power or anything along those lines. Least capabilities, right? There's a lot of metrics that define a capability of a wireless client on a network. And you want to find the one that is most important to you that you can glom onto and say, hey, this is the one that failing all others, this is the device I'm going to go launch off and get as much information about as I can. And hopefully that's a device that has well prescribed metrics and data about how it makes decisions. The conversation I usually have with folks goes something like this: do you use iOS devices in your network? And most people say yes. And we go, cool. Do you use Android devices, Windows devices, Linux devices, Mac devices, blah? And the answer to those tends to be, varied and wide. But one client device manufacturer that does publish the specs about how they roam and what they do when they want to roam and what those triggers are is Apple. And they tend to be a really, really great Wi-Fi citizen. That doesn't mean that it's one set of rules for all clients, though. And I think that's the thing that most people need to, I think that's the thing that most people really need to glom onto is that there is no one size fits all for every single device, especially older devices. Heck, even amongst newer devices, right? You can grab a brand new Android device that just roams like garbage, but it's a brand new device. Yeah, well, the manufacturer didn't tell us how it's going to roam. Yeah, that's why it's important to have an understanding infrastructure and clients top to bottom. You don't just let any employee go randomly grab a $399 PC from Best Buy and bring it into the office and set it on the desk and plug it into the corporate network. Why would you do that for a wireless client?
Absolutely. So someone was asking a question. Can you describe how best to design an environment such that each AP has a redundant AP in case the primary AP stops functioning? Are there concerns that there will be an overdense deployment of APs? What's the average square feet for AP for this type of design? 1,500 square feet, etc. Who wants to take that one?
I hear it depends coming. But
I do too.
No. The answer is yes.
Yes.
Elaborate, please.
I've seen instances where people wanted to pull two cables and just have the second one with an AP on it, just like with it waiting to take over so that it was like fully redundant. I've seen that happen. If you have gobs of money to spend, you can do that. I don't know that it makes a whole lot of sense because it's not the same thing as like having a switch stack. But
I think part of it is just, some RF design. If you want redundant coverage, I think that comes down to how you measure things like overlap and how you design for some of that. Having two APs that go into your Ekahau and design it so that you have two APs at whatever your minimum coverage threshold is. It's concerning. There's going to be probably too much coverage, right? There's going to be a lot of overlap, and depending on the environment, you could run out of channels. And the question becomes, are you okay with that? You're probably going to end up using 20 meg channels and every channel you can get your hands on in order to solve some of that. But it's also definitely like, if that's the requirement, you got to kind of approach it from those types of perspectives of how do I just achieve the things that I need in order to meet that requirement. I think that you may have to, like, if the redundant coverage is a hard requirement, you may have to look at your co-channel requirements and say, is that something I can ease up on to have that redundant coverage? And again, you're going to trade something for something else.
Well, and redundancy is one that's always intriguing because I think there's this mindset of redundant coverage is I must have two of everything. I think more people would be better served if they took a saner approach to redundancy. When we look at ambulances that drive down the road, what are the number of failures that could occur in an ambulance? Well, they're wide and varied, yet they only carry one spare tire. Well, they have 4 tires. What if all 4 tires blow? Guess what? We just don't plan for that, right? Why are you going to take and extend out about, you know, this sort of incredulous scenario of saying, oh my gosh, you know, I had 3 APs die, when you know the failure rate of APs is like less than a fraction of a percent in most instances. But at some point you do have to trust the infrastructure, and you want to take a more sane approach to things like redundant coverage, and you must have overlapping everything everywhere. Good client device manufacturers, Apple, are going to say, if you need redundant coverage, here is how you do it. And they're going to spell out, your business concern is this is how we interpret your business concern, and this is how you translate that into technical details. And they're going to say 2 APs at -65 or 67 or better. And oh, by the way, in order to accomplish that, you need more channels. And oh, by the way, our devices support those channels, and all of these various and sundry things that go along with it. There is no good general guideline, and picking a square feet per AP is of course not how you design a Wi-Fi network. I can tell you the last network I designed was a reasonably small network, a reasonably small facility. It was an office that I just did, and its square foot per AP was down in the 750 square feet per AP range. So we're seeing some extreme densities that we haven't seen in the past, and that's because of when you look at, for example, Apple says, hey, we 2 APs in all locations. And oh, by the way, you apply the offset to the Sidekick so that you're measuring sane values. And then there's a 10 dB delta or whatnot. And you're talking about 5 gigahertz only. A lot of those things coalesce to really, really having a lot of APs in your environment. This happened to be a busy downtown in New York environment. And then, of course, channel planning on top of that. It's a very, very delicate balancing act that has largely to do with your client and what you can physically do in space.
Absolutely.
Ooh, that sounded really good. Is somebody recording this?
Sam just likes to hear himself talk. Sam's bedtime stories are recordings of his podcasts and things, presentations he's given, right?
But Sam, you know, you came up, and I'll just ask kind of a follow up to that one. Is, you know, we're always talking about Apple, and Apple's kind of is a good reference, right? But you know, we've got 1 billion other those clients out there. We've got our Android, we've got our maybe we might still have some of these around, right? The you know, the Cisco phones. How do we get something that's kind of a rule of thumb to play around with all of them at once? I mean, is there something that we could, you know, look at as what is this as a whole, right? Because not every environment is going to have just that one client, so to speak.
Sure. And as far as I'm concerned, it's about being in a defensible place. Why did you do what you did? Because I had something written down from somebody that said I should do this. Now, there are plenty of device manufacturers that write down what you should do. The Cisco 7921, 7925s, 8821s, the new 860 phones, those Cisco endpoints are very, very well scripted. Motorola and symbol scanners in manufacturing. Some Samsung Knox devices are very well scripted. Mac OS devices are very well scripted, are very well defined. And then there's a bunch of devices that aren't, right? There is no guidance from Microsoft that says, in order to support a Microsoft Windows machine, you should design your Wi-Fi network like this. So you have to be cognizant of the things that are on your network and how much assurance you want from those manufacturers to say that this is the proper way forward.
Awesome. So question, Jake, is it really a good idea to interfere with the natural process for band steering of the natural process of a station connecting to Wi-Fi before forcing it to a specific band?
No. I think that there are times when you would want to, like when you're talking about doing things at scale, like large public venue, stadiums, that type of stuff, where we're trying to effectively load balance clients across spectrum. I think that starts to make sense. That said, I think artificially forcing clients places they don't want to go is a great recipe to have poor client experience. Wi-Fi clients are like people, right? If you try to make somebody do something they don't want, how good are they going to feel about that? And I've seen countless times in higher ed where you turn on some sort of band steering and it just results in clients ping-ponging because you're trying to force the client to do something that it doesn't want. And it just like, oh, I went to 2.4. I want to go to 2.4 because that's what I see is good. And you try to force them to 5 and they immediately say, sorry, this isn't good enough. I want to go back. And whereas if you just left them alone, they probably would have had an okay experience on 2.4. But like I said, that said, when you're in places where spectrum efficiency is paramount to everyone having a good experience, like stadiums and places where you have very high channel utilization across all of your channels, that's where those types of behaviors are probably warranted. But I would say, me personally, most clients are smart enough to pick what's going to work well for them. Apple, and if you just leave it alone, they'll do what is going to result in the best experience anyway. So,
folks are going to hate us that we keep saying Apple, Apple, Apple.
A certain fruit company.
So Jen, someone was asking the question. We are in their area. They are upgrading with some new AXAPs. In their previous deployment, they had MIMO turned off. In a BYOD environment, are there any best practices for beam forming or beam transforming and MIMO?
Ooh.
I would say, why would you? I'm kind of confused as to why you would turn that off, because it would be, my perception is it'd be an inherently good thing to have, like, all of the ability to hear and use signals that have been bounced and changed and whatnot, to get a better signal strength for your client devices. So I would be curious as to why they felt the need to turn that off. I haven't heard of that being something that somebody would do to make a situation better.
So Ryan asked that question. Ryan, reach out and let us know, and then maybe we can help with some additional information on that. But I am curious, taking a step back for a second. The three of you have done a lot of designs and a lot of interesting ones, some not as interesting, but I want to know, just really quick, what was your first design like? Your very, very first wireless design? Because I think that a lot of times we look back on things and we've learned a lot. We've come a long way. And I think you guys are in the position that you're in is because you have learned so much over the course of the last couple of years, right? So Jake, we'll start with you. Tell us about your very first network design and what you learned from it.
It was terrible. It was effectively a glorified drawing with solo cups. Basically, I would plot out where I wanted to put an AP, and I would go and measure to the point where I wanted that kind of cell to end. And so basically you would have like a dot in the center and then all these little lines out to different, walls or things of that, trying to of course, I didn't actually have like design tools. I didn't have, a survey application. I was leveraging, what was it? I'm pretty sure. No, it was like the old Cisco
the PCMCIA card app that showed you the signal strength.
Yeah, the survey thing. And so literally
Yes.
it was, I had a clipboard with a floor plan, and I was walking and measuring numbers and writing them down. And then I would move my AP on a stick to the next spot. It was pretty terrible. It took me like a week to do this, and it was a lumber facility. And I think it was maybe 30 APs. So it wasn't very fast either. So, but it did mostly work. So I feel good about that.
What was the biggest lesson you learned from that? That you need tools?
Actually, that was probably the biggest lesson. I went to management and said, listen, we can't do this. This isn't practical. I need something to be able to make this easier. And yeah, the result of that was a tool discussion. So.
Tools definitely. I think that's one of the reasons why we get so excited about Ekahau Connect here, just because, to your point, Jake, without tools, we can't do anything. It makes we would be stuck on projects forever if we did.
Yeah, I mean, when I started, I got handed I believe it was a Proxim 8494, and said, go figure this out, with no tools or anything behind it. I did a lot of like NetStumbler. I did a lot of Linux and Kali Linux. I was Backtrack back then, but trying to just measure what I needed to do to make things work. And it was terrible, but.
Awesome. I love hearing people's stories. Jen, what about you?
Yeah, so I use the same Cisco survey tool to on a paper map to draw out with colored pencils the signal coverage for each given access point that I was putting in. And then I used Microsoft Paint and 3 different colors to create my little heat map of where the APs came out and like where the overlap happened. And the thing that was my biggest takeaway is after I'd done my survey and I'd plotted out like where my signal started to drop off around like -70, was that the feedback that I got was that the client devices still had really bad experience and they were simple handheld barcode scanners. And that's when it became abundantly clear to me that the Cisco card was vastly superior to the wireless card that was in those simple handheld barcode scanners, because those things really, really didn't work, even though I had great signal strength where they were. And it was like, well, yeah.
And that was before Ekahau survey existed, right?
Oh man, this was like 2002, long time ago, 2003, like forever ago.
Yeah, you know, it's funny. The chipsets and the products that we've had have come a long way in a lot of different aspects to think about that, right?
Yeah.
Sam, what about you?
It's embarrassing to say, I suppose, to say the least. You guys have
there's no one here but us girls.
Yeah, just us. You guys have this wonderful slide that shows like the evolution of surveying, where you've got like, you know, the guy with the laptop, and then like with the sidekick, and then like the phone, and like he's dancing. If you rewind that image to the left, there's a couple other steps that include the guy like licking his finger and sticking it up in the air to figure out where the AP goes. That was what I was doing. It was an office in Northern California, and I had one of those black housings for APs that had PCMCI or PC cards in them, and you put one in or 2 in if you wanted 2 radios, and they had gold security, so they were awesome, and just put it up on the wall and walked around the office to see if it worked, and it was terrible. I mean, it worked, but you know, at that point there was no, you know, we didn't have to deal with neighbors, we didn't have to deal with density requirements, we didn't have to deal with bandwidth concerns, we didn't have to deal with any of that stuff. A T1 was super fast, so if you were getting 1 megabit per second data rates, man, you get 2 or 3 clients that could do that, you were most of a T1 already. Why would you need to go any faster than that? So yeah, it was awful.
Well, so thinking back on those designs and now where you're at, is there one thing that you would recommend for folks going forward in wireless? Like, what do you think is the one thing that they should never forget, and always make sure to include or focus on when doing a network design?
Lots of saliva keeps the finger wet. So you can go like this, and then you can say, yep, feels like it needs to be over here.
Right?
That's not a real tip, Sam.
You wanted a real tip.
Yeah.
I'll let somebody else go first.
Well, my first design was primarily outdoor. Well, yeah, primarily outdoor stuff. So we were mounting indoor rated access points under like sad overhang environments and like using directional antennas. So consider that you're using the right AP for the right environment. And if you're using indoor APs, protect them from the weather, use external antennas, put them in a NEMA box or a Tupperware box or something. Because you don't always have the luxury of spending the money for an outdoor rated access point, but you may find out that you spend that amount of money trying to get it weatherproofed. An indoor AP in the right enclosure often equals the price of an outdoor AP once you're all done, if you're going to do it right.
Yeah, absolutely. And the enclosures I mean, there's some amazing things folks are doing to hide it, to, you know, modeled into theme parks that they are hidden. You can't even tell. Absolutely, absolutely amazing. Jake, what about you?
I think, at least for me, I'm always guilty of being the technology guy, and, you know, doing things because this is the technology thing we should do. And I often forget that there's a whole group of other people out there who are not that way, and trying to understand the business requirement. I say business requirement, but try to really understand what the requirements are from a business perspective of, hey, Jake says we need this. And it's like, well, we don't really need that. What we really need is I need Facebook to work on my iPhone in the bathroom. That's what I need. And so understanding what people really want versus, versus what they say is the part that I think you spend the most time, because, and it's also one of the reasons I like that pre-site survey, is because going on site and seeing what people are actually doing, what they actually are struggling with, can sometimes be more valuable than all the RF planning in the world. When they went in and drew the big red box and said, don't put Wi-Fi in this area, and you don't, and then that's the place where you're going to get the most complaints for the next 5 years. So I think try to understand what the non-technology folks are trying to achieve, and just make sure that you're going to meet those requirements. Because I think as technology folks, we get hung up on that piece of it and less about how people actually use the stuff.
That's really good advice. Sam, what about you?
What he said. I
So
mean,
not it depends. Just
no. I mean, I think you hit the nail square on the head, which is devices are important, but who uses devices, users, and how you use the device can have a significant impact on how you would design a Wi-Fi network. And so as Wi-Fi designers, we have to make sure that we're cognizant of balancing not just the technical requirements about, hey, what should your cell boundary be? Hey, what should your data rates be? Hey, how much throughput should you need? But hey, there's this application on this device, and this application needs to work, not this other thing. You roll into a healthcare environment that wants to run Volt on a phone for patient care engagement, and guess what? You may design that network a little bit different than you would in a corporate office environment where they just say they need iPhones.
Yep. And Sam, that's an interesting one, because I spent time in that space, and it's tough because you ask the question and the client says, well, we just search. That's all that's important. But then you have to ask the question, well, what are you using it for? Is it for Vocero traffic? Is it for an application that is transferring imagery from an imaging device back and forth on the network? Is it no guest and it's just doing a certain application? Then that's where it comes into, well, this is why we need redundancy. This is why we need a thing. So always asking the questions is a key thing.
Well, and I think that's a skill to develop for technology folks, to Jake's point, is to ask them the leading questions. If you just say, I need coverage, what is your follow-up to that? How are you using it? So exactly, you have to peel back the layers and understand exactly what they're trying to say. And that is an art form in and of itself, to be able to keep leading them down the path to get the information that you need to build the network so that you can build something that meets their needs. So Jake, you had mentioned surveys. So if a customer has multiple locations, a lot of 50 plus locations, right? Or whatever it is. Do you recommend doing a pre-install site survey on every location, or kind of like a hybrid model where you're doing some and then it works in these environments, so you're going to do a predictive and roll it out to the other locations? Do you have some best practices or thoughts around that? I
think the more you can do up front, the more success you're going to have, and the less problems you're going to have in the long term. That said, I've seen people be successful not doing it, but it also it depends the state you're in and what you're trying to accomplish. If your requirements are, if the bar is low for what success is, you can definitely get away with not doing anything. If you have, I've seen clients do things where it's like, do executives sit at this site? If yes, pre-site survey. If no, just do predictive and deploy. And you can get away with that because the people who are signing the checks are happy. But I think the more you can do upfront, the better and more successful you'll be. I think that you have to start, doing things in order to try to mitigate some of those risks long term. I have customers who say, "Oh no, we're not going to do site survey," and they pay for it. I think there was somebody who did a thing that says it costs the same whether you do it up front or you fix it later. I can't remember who did that talk at WLPC, but it definitely is something that you can. I think the direction I see more folks going now is using those resources efficiently. So at work, I have customers that will go in, they'll deploy, and then they'll leverage, the machine learning and AI that says these sites are doing well and these sites are doing poor, and say, okay, well, these are the sites that we need to invest that money in to go back in and remediate and improve, where these other sites now, save that money and put it to the places that really need it. So I don't necessarily always agree with that. I think that there are things that you lose, like first impression. Like when I go change the box on the ceiling out to something new, if people have a poor experience, they associate the poor experience with the logo or the box on the ceiling. And so that can be difficult. There was a university that did a study. They had a botched rollout. They rolled out Wi-Fi across their campus, and they messed it up. And it took them 6 months to remediate. And what they did is they surveyed all of the students every year for the next 8 years. And what they found is that students that were freshmen, the year they botched the rollout, consistently rated the wireless experience poorer than students on every other year. And so, you only get one shot to make that first impression. And if you screw it up, even if it's great, those are still going to be the loudest complainers and the people who think your network sucks, whether it does or not. And so me personally, I'm a believer in doing the work up front and reaping the benefits down the road. But, everyone has to choose and mitigate that risk in their own way. And sorry, long answer.
No, that's exactly right. I think it sometimes you have to make that determination. Can you, what is the opportunity? But the first instinct should be to push for that, to mitigate that risk, because network downtime and outages are very, very costly for organizations. So I agree. I think that's absolutely something we should be pushing for, and having tools available in every location so that we can get the information that we need to do that is really critical, is really important as well.
And I think it comes down to, and this is the decade plus in sales of, hey, start with, the Cadillac, right? This is the thing that's going to make you the most successful, and then settle on the thing that you can live with, right? So always buy the big AP until you can't afford it. And then it's like, well, which AP is the one that I can get away with and still be successful? There's a reason we go that way. It's like, what's the easiest way to have the least amount of pain? And people make decisions based on pain. And so, but conversely, if you go in and say, we have to site survey everything, and that process is exceptionally painful for the business, they're going to make decisions based on pain too. So you have to kind of balance that.
Absolutely. So switching gears really quickly. So someone was asking the question, we had talked about band steering on client devices. So would you recommend just splitting the SSID, having a 2.4 SSID and a 5 SSID versus, I like the reaction. Yes. Who wants to take that one?
No.
You could make the SSID like super fast Wi-Fi and like have that, you could. If you want people to like opt in to the Spectrum choice, you could, but I don't know, you could end up making more work for yourself in the long run trying to do it like that.
Yeah, that's a difficult one, because you have to make some assumptions about the client devices in your infrastructure in order for that to be successful. Which is, hey, if I have 2.4 GHz only devices, what are those devices' network requirements or expectations? And usually, if let's say better than 90%, those devices don't need the redundant negative 65 dBm coverage with platinum QoS and lots of channels and all that fun stuff. They're your Ring doorbells, they're your Wemo remotes, they're your IoT centric devices, and those things can get away with connecting every once in a while and sending out a little bit of data. And so you have to balance, do you use something like band steering to try and push them away, to try and push 5 GHz clients into where they need to be? Do you have dual SSIDs and then the burden is now on the person who's configuring the devices and they could get that wrong? Or do you just tank the power level of your 2.4 GHz radio so that they don't look attractive to the things that that could be making that decision. And I don't think that there's a wrong answer. It's where do you want that pane to be, and who do you want to ultimately be on the hook for making sure that those configuration widgets are mashed properly. If it's the desktop support team and you say, hey, when you're configuring these machines, make sure you don't pick the slow SSID, you know, your mileage may vary. But I think there are some design related things that you can do to mitigate that. Tanking your 2.4 gigahertz power levels, for example. There's also things like band steering, and I think that all of those options together give us essentially a toolkit's worth of stuff to try. And I think that's the important thing. Not that there's one thing that everybody uses, but that there's enough options that whatever is right for your site, you have available at your disposal.
So in kind of related to that, someone was saying that they have a lot of interference on 2.4 and they cannot remove the source of it, and so they're having issues. Would that be your recommendation, to crank down the transmit power for the 2.4 to kind of force them to, you know, the devices to 5 gigahertz, or what?
No, in those situations you crank it up. You have to yell louder than the thing yelling at you.
Yeah.
Jen?
I would, yeah, that's a bad situation to be in. But yeah, I would say in those situations, if you have unavoidable interference that's not going away and you can't find it, you can't get rid of it, then yeah, your 2.4 is probably going to have to shout louder than the interference, and just hope for the best. I've seen that where it was like, I think it was like an HVAC system or something like that. It had some weird harmonics that affected in the 2.4, and it's like, you can't take that out. So you just have to work around it as best you can, whatever that looks like.
You know, one of the stadiums that I turned up had a 2.4 gigahertz protocol compliant, super noisy thing, and it was just trashing 2.4 gigahertz top to bottom. And the business decision was made to not expend the time, energy, and effort to locate the device and mitigate the device, but to simply stop supporting 2.4 gigahertz on the wireless network. So that's a really great example of, hey, there was a business that said they balanced the cost of doing of sort of path A and path B, and path B was the one they picked, even though they may strand some clients that are super old. Now in stadiums, you may not run across that. And so your mileage may vary. Is your mileage may vary now the new it depends?
Yes.
It depends in that your organization ultimately has to balance the pros and cons of saying, well, if I really do need to support this, then I have to make a decision about how much time, energy, and effort I'm going to spend mitigating it, because it could be extensive.
Absolutely. So another, switching gears, BYOD networks. Any tips or tricks for devices, do's and don'ts on a corporate SSID for BYOD? Don't all jump at once.
I think a lot. You got
have a good relationship with your security team.
Yeah,
and I think that goes into one of the Q&As, is, you know, asking about, you know, what's like a BYOD policy for devices on corporate SSIDs, like, you know, and that's a you know, Jake's right, you know, understand what they want and what's allowed, and then you can kind of start the conversation, right?
Well, and I think making sure that everybody is using the same term properly, much like the word survey, right? You say the word survey and it could have 1,000 different meanings. You say the word BYOD and that could have 1,000 different meanings depending on the organization you're talking to. My definition of BYOD is different than other people's, in that BYOD for me is that instead of getting a corporate owned asset, you are given an allowance for you to go buy your own device, and that asset is owned by the organization. Therefore, it's subject to MDM policies. We pay for it. We can manage it. And those things are you just play a money game, right? Where the company is giving you dollars to go buy the thing you want, but they still retain the asset. That's a BYOD, not transient guest, right? Not, hey, my CTO came in and his iPhone, he doesn't want on the corporate network. He just wants to get Facebook. That's not BYOD in my book. That's transient guest access. And so you have to make sure that the terms you're using are everybody agrees to them, so that you can understand what the goal of your BYOD SSID is. And then at that point, you can go through the various and sundry machinations to say, this is what we're going to do. This is what we're going to do.
And I think the security team, like, once you kind of identify those use cases, like this is transient guest, this is employee personal device access, this is, you know, a BYOD device with corporate access. Once you have those, then it's really easy to map those with your security team into how you're going to authenticate and identify them, and then how you're going to treat them in terms of access control. But like I said, having that relationship with the security team, defining what those levels of access are, and then getting them to write the policy, and then it comes down to the network team to enforce it.
Someone is asking the question, what would happen if we deploy AX APs mixed with 11 AC APs? Is it going to be smooth for client roaming, or are they going to have issues or problems?
Yes. No. So
potentially,
potentially, yeah,
perhaps.
So one thing is, this comes back to the stupid client device like logic.
Yep.
Apple is very good about documenting kind of how they prefer things. You will find that Apple has preference for capability. They think that a more capable AP will result in a better experience, and therefore they will pick things. So introducing APs with newer, faster, better capabilities can cause those clients to become sticky. So I'm only going to roam to the 11 AX APs, and I will skip over the 11 ACs because I think that AX will give me a better experience. So you do have to be a little careful when doing that kind of salt and pepper approach. But that's been the case, intermixing AC with 11N. It's been 11N with 11 AC. So nothing new there, but it is definitely something to think about.
And I think that's comes into that enterprise APs, right? I think that might be what you're talking about. You gotta mention too, Sam, is remember the old days we said, well, not the old days, but generational APs, right? That had this capability. And if you did that salt and pepper mix in that type of environment, you're gonna have that, it's mixed results, right? Going between those.
You could run into a bug on one hardware platform that's not present on the other hardware platform, and trying to track that down as clients roam from hardware difference to hardware difference is a nightmare.
Yeah, even if it's the same brand, right?
Yeah,
but,
totally.
But generational, whole mixed different ball game, right? So,
and I think it's important though to understand that this is a client problem, generally not an infrastructure problem, and that most infrastructure manufacturers will say, yeah, these can coexist perfectly fine. RM's going to work, roaming's going to work in a given set of clients. They're going to say, hey, you have the right version of code, these are all fully interoperable, this, that, and the other. And so this is generally not an infrastructure problem, but it ends up being our problem because we have to deal with clients. And so it's one of those things where if you dig into the gory details, I think every vendor everywhere is going to say, if you're generationally rolling out APs, collapse all of one generation to one area of a building, and then collapse all the other generation to another area, so that when you do roam, you are in a contiguous technology area.
Good advice, yeah.
Absolutely. Before we switch gears, it's time for another poll question. So for those of you, when are you going to be upgrading or designing a new network? 0 to
Clearly,
12,
there's
12 to
only
18,
one. There's only one right answer.
24. Sam, I left it depends off on purpose. All right. Stu, where's my Jeopardy music?
Oh, it's playing. You can't hear it?
I can't.
What?
Oh, see, now I hear it.
Oh, there you go.
All right. So it looks like we are going to have a lot of really busy engineers and architects in the next in the next year, right? Lots of upgrades, lots of refreshes coming. So folks, hope you find these tips and tricks helpful. As we've got a few more minutes, we'll try to get to some more of those questions. But yeah, it's interesting to think about how design what's going on over the next year, right? There's a lot happening. There's a lot of things to consider, and especially as we all start coming back to work from COVID and things start picking up, and okay, well, we waited because no one was in the building, and now they're coming back into the building, so let's pick some of these projects back up. So it's going to be interesting to see what happens, and I think that's why we're seeing a huge jump in that 0 to 12 month range. All right, so still lots of questions. Thank you, everybody. We've got about 10 minutes left. Stu, any questions that stood out to you that you wanted to to make sure we get in?
Yeah, I think there's a couple in there that I like that we could spend some more time on. I think a lot of folks want to spend some time on the airtime utilization and co-channel interference, and how do you plan for that? How do you what is it like? When I get into bigger environments and you talk about stadiums and airports, right? And I think that's something that that we could do on another session is those type of high density. Right. And so, how do we best overcome that? And that's really what that question is from from one of the guests, right? It says, yeah, I think we should kind of look into that a little bit more. But I mean, overall, is that it's all about listening to the customer's needs and what is they're trying to accomplish. But as Jake and Jen have Sam's put it, is that you have to kind of prod and understand, like, hey, what do you want to do? Tell me what you really want to do, and then go and observe if you can. Because if you're designing a big multi-faceted office that does a bunch of different things, this office may have distribution and office and guest and critical infrastructure all in one building. It can, or campus. You need to see it in action, understand how they're doing it, how they're going in between the office space and the warehouse with the same devices. Understand those questions, and then you can have a better sense of how to design it. And it'll make sense because you talked about roaming SSIDs, right? Jen said, well, that's going to be a trade-off. I only support, should I have 2.4 gigahertz ones and 5 years separate? Well, maybe I want to have one so I don't roam between two different APs.
Well, so let's ask that question. How do you overcome airtime utilization or in dense environments? Any recommendations?
Yes.
I've seen improvements happen by having customers reduce the number of SSIDs that they had running at the same time. I think they had upwards of like 8 or 9, and when they brought it down to like 4 or 5, they saw a huge clearing of the noise floor.
Yeah, I would say that it's, I think as is with most things, it's design first, right? So make sure that you're not doing silly things like stacking a bunch of 2.4 gigahertz APs up on top of each other. Then everything else is going to be, like Jen said, SSID reduction or disabling low data rates, right? Those CCK data rates are super inefficient from an airtime perspective. And when you have multiple SSIDs, you're beaconing all day long, and every AP beacons for every single SSID, and that's needless spectrum that's being consumed. Now disabling low data rates, though, I think is also hotly debated in that I think a little dab will do you. There's a point of diminishing returns, and so you what you don't want to do is you want to say, well, if I disable 1 and 2 and my noise floor drops from, or my channel utilization drops from 80 to 20, then if I disable all the way up to 36, then I must be good, right? Like let's just crank the knob all the way over there. Yeah, yes, not so much. And so it's one of those things where you have to make a controlled movement and then go and measure and make sure that you haven't broken anything. Diminishing returns, I think, on channel utilization around the data rate topics is probably the one that could use some finessing.
That's fair. So someone was asking a question. Would you recommend to a client that has a 4-store building different AP models or different AP brands per floor with the same SSID?
No. I think the worry is, and in fact, we run into this a lot of times when we're doing proof of concepts of a network, especially things like fast roaming. We're not exchanging keys with other manufacturers, right? So I'm not forwarding those keys to the next floor of APs, and so if you again, you would want to, I mean, doing it per floor is better than like scattering them across floors, but generally you're going to have some sort of impact between, when you roam from one contiguous Wi-Fi system to another. And there's no real good solution to that. The best options are doing things like disabling 11R and fast roaming, making sure you implement features that are consistent across all manufacturers. But if you had the option to not do that, that would be better. But that said, we did a proof of concept where we had, our APs in one area of one floor and then another manufacturer elsewhere with the same SSID. And the biggest thing that we saw improvement of was turning off 11R so that they did good old standard slow roaming, but there was no expectation that the next AP had the key. And that did help quite a bit. But like I said, keeping your data rates and your channels consistent and things like that can help, but there's still a lot of opportunity for issues to arise.
Mm-hmm. Someone was asking a question. Any best practices for designing in an elevator where the elevator needs Wi-Fi coverage?
Depends upon local fire code. You can put an AP at the top of the elevator shaft and have it move with the car, but it depends upon the local fire code. So I would say check with whoever I don't know who you'd even call, but I know that's the gotcha, is the fire code regulations for the area.
I see fire code coming into play more in stairwells than I do in elevators. In elevators, I think I think that more and more organizations, when they go to Otis or ThyssenKrupp or whomever, and they're putting in their elevator, they're checking the box that says yes, put fiber in the cable tray, so that you can you can just treat your elevator car as an IDF. And so you take and you put a switch into that IDF with a fiber uplink, and you put an AP in the roof of the elevator car, and you don't even have to do any penetrations or anything along those lines. The problem comes is when somebody was looking at budget and they go, wow, why do we don't leave that line item on the elevators? Uncheck. And then you now have to go back and retrofit that fiber into the cable tray car of the elevators. And they're not cheap. I think the new options, when you spec it new, it's like a $20,000 option per car. And when you have to go back and retrofit it, it's something like $40K per car. And so these are all problems that money can fix. But good night. I guess a lot of money.
Well, we are at the top of the hour, so wanted to give you guys an opportunity. Any last final thoughts that you would like to share? Anything, any tips, things to stay away from, things to make sure you do? Any final thoughts? Jen, we'll start with you.
Goodness gracious, now I'm on the spot.
And while you're thinking, I'll give you a second to think. So thank you again, Jake, Jen, and Sam for joining us. We truly appreciate you taking the time to let us put you on the spot and answer a lot of questions that Wi-Fi folks have. But folks, these three individuals are very engaging on Twitter. If you have a question, if you want to know something we didn't quite get to the question you had today, please feel free to reach out to them. We're volunteering them to answer and interact with any questions that you have. And please feel free to reach out to them on Twitter or anywhere that you have access to do. But thank you again for joining. With that being said,
okay, I got it now. Now that we're out of the Stone Ages and that tools actually exist to look at spectrum and to simulate other client cards and like other client experiences, use the tools. Don't design with one client device in mind. Yeah, check it out. Use the tools. They're out there.
Absolutely. Sam?
Yeah, I think if there was one parting thing that I could leave with folks is that I think Wi-Fi design is always a balancing act, much like insurance is. And I think that somebody said that in the chat, is that you want a good experience for your users, and your users are going to demand a good experience. It's up to you to deliver that good experience proactively or after they've yelled and screamed at you. The cost is going to be the same, if not more, if you do it after the fact. And you're going to incur a bunch of black eyes and a bunch of dissatisfied users, and you're never going to shake that bad rap. I think it's incumbent on all of us who are passionate about designing Wi-Fi networks to do it right the first time, right? Do it up front, do it properly, and then save yourself the headache. Now, nobody ever gets an award for, doing things right the first time because there's no complaints. I get that. But, I that's a highly personalized opinion. But that's where my head's at.
Thanks, Sam. Jake.
So there was a question about like, how do I justify like tools to management? And I think that what I would say is that as we start and learn and grow as wireless engineers, it's a feedback loop. You design, you deploy, and then you find out how unhappy your users are. And I think that when you go to management and say, this is not just a tool to help me design Wi-Fi, it's a tool to provide feedback for myself so I can continuously improve how I engineer the next building and the next site. And I think if you approach it from that perspective, I think management will be very good about that. But I also think it makes us better engineers. It makes us better engineers more quickly. You don't have to go screw up 100 networks before you learn those lessons. And so you only have to screw up. I always joked with my employees that you're going to royally screw up 5 networks in your career, and the goal is to get those as few and far between as possible. And so leverage those tools, use it as feedback, and use that as a loop to improve not only your Wi-Fi experience, but your skill set and knowledge of how stuff works.
Absolutely.
Well said.
Yeah, well said. Once again, thank you guys. Stu, anything you want to throw in and add?
Well, I
just kind of want to say amen.
Amen. I think that I added a little bit too early on the last comment, because I looked at the time. I'm like, oh, what was I was over? Anyways, I think that we covered a lot of great stuff here today, and I think that this will lead into further discussion, because we had some great topics. We're all setting ourselves up for kind of being better wireless, planning, designing, putting things together, and creating better outcomes.
Yeah, absolutely. Well, thank you folks for joining us today. It has absolutely been a pleasure. Once again, thank you to our lovely and amazing panel of experts. Thank you for taking the time from your busy schedules. And with that, everybody enjoy their morning, evening, and midday.